Okay, video 2 here. So this time we're going to have a look at dynamic equilibrium. And we're going to look at the factors affecting dynamic equilibrium. Okay, now we've got one that stands out on its own, and that's temperature. Okay, then we've got two that work very much hand in hand, or their explanation is the same. So temperature, and then we've got concentration and pressure. So those are factors that affect equilibrium. Okay, now we have another one that we usually investigate as well, is catalysts. Okay, but we'll put a bit of a question mark beside it because catalysts speed up the rate of the forward reaction. They speed up the rate of the reverse reaction equally, so you end up at the same end spot, just quicker. We'll learn more about that as we go along. Now, altogether, these are explained by Le Chatelier's principle. Okay, so temperature, concentration, pressure, and not surface area, that's rates. Catalyst, now if we've got all that, we've got subject matter 8, 9, and 10. Now, because we've got this dynamic equilibrium and we've got reactants going to products, we can write an expression about that. We can develop an equilibrium law. Okay, now with that equilibrium law, we can write it a general equation such as that, and then we can take our equilibrium constant, which is we call Kc, and we can write an expression. And what we do is we take the concentrations or pressures, it possibly is, concentrations of our products, raise it to our stoichiometric coefficient, to the power of the stoichiometric coefficient, and then do the same with the reactants. So the concentrations of the reactants, raise it to the power of the stoichiometric coefficients, small a and small b, there's small a and small b there. Okay, we can calculate those values, and if it turns out our equilibrium constant, Kc, is greater than 1, then the products are favoured, and if Kc is less than 1, the reactants are favoured. Now make sure you get that concept and how the maths works here. Okay, so if we've got all of that, then we've got subject matter 11, 12, 13 and 14. Okay, let me try and find where 15 is. One of the particular types of substances we will look at in regard to chemical equilibrium are acids and bases. Okay, so acids and bases. Last year in year 11 we looked at the Arrhenius definition. Now we're going to look at the Bronsted-Lowry definition, which is a more encompassing definition. We again will look at weak versus strong, but we'll also look at concentrated versus dilute, and we will remember from year 11 that weak and strong, concentrated and dilute are totally separate. Okay, we will go further into what the pH scale means, and in particular we'll do a fair bit of work with this equation. Okay, that's our definition for pH there. We will then derive a term called Kw, which is a form of the equilibrium constant. Okay, from that Kw, we'll look at the equilibrium constant for acids and the equilibrium constant for bases. With water, because this is water, which we'll put here because it's from the equilibrium law, Kw. We will learn that water is what we call amphiprotic or amphoteric. And that's probably about it there. So we're going to, Bronsted-Lowry, we'll be looking at subject matter 15 and 16. Kw is subject matter 17. Then pH rules. There's various ones of those, quite a few rules there that we'll have to know. Then we'd be back at Bronsted-Lowry, subject matter 20, and actually 22 goes there as well. 21 is the amphiprotic, 21, 22, so 23, or amphiprotic we will then look at conjugation, which then leads us to buffers, and that's where SM23 is. Okay, it's in those two concepts there. 23, SM24, SM26 there. 25, I'm just trying to look it up. Oh yeah, Ka and Kb. So we're looking at SM25 and 27 there. Okay, I might stop the video there and we'll make a third one. Oh, I've just noticed I've been off the screen, so okay, pause the video if you need to follow there. Okay.